Imagine a super tiny, minuscule condensation of raw energy, smaller than anything you've ever seen or comprehended, many times smaller than the smallest atom. Imagine if it were to erupt, expanding quicker than the speed of light. No one really knows when, where, or why it happened, just that it did, and it was violent and hot. Let's conduct a thought experiment to see what happens next. Imagine a perfectly still pond, one in which every molecule is perfectly stationary and ordered, every atom inanimate, and there are no fish. Now we go to all individual molecules in this pond and simultaneously push them with different forces and in different directions. In no time, the whole pond comes alive. It produces sounds, the vibrations ripple, and waves start forming on the surface. Freeze this frame and consider the following. You now have a disordered, almost chaotic environment of high-energy particles moving in clumps like wrinkles within the fluid composing the pond. The larger the size of the pond, the higher the likelihood of some wrinkles matching others in mass, composition, the frequency of their vibrations, and their directions. These wrinkles could potentially collide and create larger clumps of motion, or they could dissipate. But ultimately, as long as they exist, they will interact with their surroundings, and anything that falls into the pond either gets wet and soggy, or it doesn't. These are the principles of string theory. The pond is the universe's multiple dimensions of space and time. The wrinkles are the energy expelled in that initial eruption, coming together to form identifiable particles that interact and can be categorized. The influence of fields can be thought of as whether or not an object gets soggy when it comes in contact with the water. That first point is known as the singularity, and the explosion is the Big Bang. Within its wake, and only there, is everything we've ever known, do know, or will ever come to know. Over the next few milliseconds, the universe expands from the singularity to the size of our solar system, and is constantly and to this day accelerating in its expansion. The aforementioned compositions of energy start to share certain characteristics with other similar clumps to form subatomic particles and later atoms, while others get different roles, and altogether they play the opera of existence. While the sheer amount of energy in the universe remains constant, as we expand further, the concentrations begin to diminish, and temperatures drop. With such cooling, there appears to be less inherent chaos, and the fabric of space-time defines itself and develops rules for how the energy within it behaves. These are called the fundamental forces, and are the true, unbreakable laws of physics.